Assalamu alaikum. Assalamu alaikum. Now today I'm with the numericals and questions on conservation of momentum, as I promised in my previous video that I will be giving one lecture on the numericals to be solved related to law of conservation of momentum. Okay, two videos were already uploaded. One was related to simple momentum and impulse, and that included some questions as well. And the second video was related to law of conservation of momentum, in which I discussed some examples, numerical examples of law of conservation of momentum. So here there are some questions from IGCSE and GCE O levels. Okay, so the first question is, a car of mass 1000 kg traveling at 8 meter per second collides with a station lorry of mass 3000 kg that is traveling at 2 meter per second in the same direction. So both bodies were traveling in the beginning in the same direction. After colliding, the two vehicles stick together. What is their speed after the collision? Okay, so here both the bodies were they are moving with the different velocities, masses are different, and they are moving in the same direction. Okay, so suppose we will take the direction of motion in the beginning towards right. Okay, so I will just give you pictorial view to you. Okay, so here there are two bodies which are traveling at different speed. Okay, this is one body. Okay, and the other one is, what is the mass? Let us have a look at the question. Uh, 1000 kg. It's a car. It's not toy car. Mass is 1000 kg traveling at 8 meter per second. 1000 kg. And it is traveling, suppose towards right, 8 meter per second. So there is another body, and that is lorry, and the mass of the lorry is 3000 kg. So if this is M1, this will be U1. This is M2. What is the velocity with which this lorry is moving initially? Lorry is moving at 2 meter per second. Okay, of course, the car is moving faster. So that will be catching up with the lorry, and now they stick together during the collision and they move with the common velocity. Okay, so the famous formula will be applied here. Okay, so this is a car. It's too big for a car anyhow. Lorry 3000 kg and it is moving at 2 meter per second. Okay, after the collision, car and the lorry stick together. Okay, so what is the total mass? This is M1 and this is M2. So M1 plus M2, that will be 1000 plus 3000, that is 4000 kg. And they move with the common velocity because they are moving like a single body. So their common velocity is to be found out. So we will apply the law of conservation of momentum. Here, sign convention is not a big problem. Why? Because the two bodies are moving in the same direction and we are taking right positive. Okay, so before collision, M1 U1 plus M2 U2. What is the total momentum? Total momentum before collision. So 1000 into 8 plus what is the mass of the lorry? 3000. And what is the velocity with which it is moving? 2. So 8000 plus 6000. means the total momentum before the collision is 14,000 kg meter per second. So which formula will be applied here? M1U1 plus M2U2, that is total momentum before collision. And this is after. M1 plus M2 into V. What is M1 plus M2? 4,000. Okay. So 14,000, we have already worked it out, equals to 4,000 V. So what will be V? 4,000 divided by 14,000 divided by 4,000 means 4 3s are 12 and 4 5s are 20. So this will be the common velocity of the two bodies after collision. Okay, answer is A. Now second question. A visitor to a fairground throws a soft object of mass 0.12 kg at a coconut of mass for 0.48 kg. The soft object stops moving when it hits the coconut. In order to dislodge the coconut, it must be made to move at a speed of 0.1 meter per second. Okay, so it means in the beginning, momentum of coconut was 0 because it was stationary. Okay, and the fairground, the visitor, he throws the soft object, it had a momentum. Okay, and this velocity is not given. The mass of the soft object is given, that is 0.12 kg, but its velocity is not given. But the initial momentum of the coconut is 0, and final momentum, what happens? The soft object stops, means the momentum of soft object after collision becomes 0. It means the loss in momentum, it loses the momentum. Loss in momentum of soft object is equal to gain in momentum of coconut. Okay, coconut has initial 0 momentum in the beginning. So whatever is the momentum, it has difference in momentum is the final momentum minus 0 of the coconut. So let us see how this will be solved. This is question 2. This worksheet contains law of conservation of momentum. And in the previous class, I discussed the question on impulse and momentum. So both the questions are in a worksheet, and I will give the link of this in the description of this video, inshallah. So you may get the worksheet from there. Okay, so here the soft object, its mass is 0.12 kg and it is thrown with certain speed u1 which is not known, and this is your coconut. Okay, and its mass is 0.48 kg, and in the beginning it is its momentum is 0 because its u2 is 0. So total momentum before collision is equal to M1U1 plus M2U2. 0.12 into U1, velocity is not given. Okay, plus M2 is 0.48, but its velocity is 0. So its momentum is 0. So what is the total momentum before collision? 0.12 U1. Okay, and after collision, the soft object stops. Total momentum after collision is equal to M1 UV1 plus M2 V2. So this one stops, V1 is 0, and this one has the momentum and it moves with the it has to move with the velocity of 0.1 meter per second as is given in the question. So 0.48 into 0.1. Okay, so we will apply the law of conservation of momentum. That is total momentum before collision equals to total momentum after collision. 0.12 u1 is equal to, this is 0. Okay, initially it was 0. The coconut was at rest. So 0.48 into 0.1. So that means 0.048. So what will be the velocity with which the soft object was approaching the coconut? U1 is equal to 0.048 divided by 0.12. So what will be the answer? 0.048 divided by 0.12, 0.4. Okay, so our answer is 0.14 meter per second. So answer is B. Now let us go to the next question. In the beginning, there are worksheet, the MCQs, and then there are some structured questions from both IGCSE and GCE. Okay, a ball of mass 0.16 kg is moving forward at a speed of 0.5 meter per second. A second ball of mass 0.1 kg is stationary. The first ball strikes the second ball. The second ball moves forward at a speed of this. What is the speed of the first ball after collision? Okay, so it means the second ball does not stop as it happened with the soft object in the previous question. Okay, soft object is stopped after colliding with the coconut, but here the ball continues moving. Okay, so here the first ball strikes the second ball. Second ball velocity of the second ball is 0.5 meter per second. So we should now apply the law of conservation of momentum and the data as well. Let us see. Okay, so this is the ball. Okay, and what is the mass and the velocity of the ball? Mass is 0.16 kg and the velocity is 0.5 meter per second. And the second ball also moves off with the same velocity after the collision, which was in the beginning stationary. And yes, 0.16 kg and 0.1 kg. This is M1 and this is your U1. This is the second ball and it is having 0 velocity in the beginning. U2 is 0 and its mass is 0.1 kg. And after they collide, they don't get stuck up. They move like two bodies. And the second ball moves off with the velocity of 0.5 kg, 0.5 meter per second. Okay, what will be the velocity of the first ball, M1? 0.16 kg is the mass. And what is the velocity, V1? This is to be found out. And this one, second ball of mass 0.1 kg, it moves with velocity V2 equals to 0.5 meter per second. So now let us apply the law of conservation of momentum, M1 U1, total momentum before collision is equal to total momentum after collision. Here the masses are not added up because they don't stuck up. They don't move like a single body. So M1 V1 plus M2 V2. So 0.16 into 0.5. This is 0.1 into 0. So that will not be there in the equation. equals to m1.16 and v1. V1 is to be found out. M2.1 into 0.5. So 0.16 into 0.5 will be 0.08 equals to 0.16 V1 plus 0.05. 0.1 into 0.5, 0.05. So 0.08 minus 0.05 equals to 0.16 V1. 0.03 equals to 0.16 V1. The velocity with which the second ball moves off, V1 is equal to 0.03 over 0.16. 0.03 divided by 0.16. So 1.17. Meter per second. The initial velocity was 0.5. There may be any error. Let's check, of course, because let me see once again. Let me solve it on the calculator. 0.03 divided by 0.03 divided by 0.16. The answer is 0.18. There is some problem, I think, in the calculator of my computer. The answer is 0.187. Let us check the answer. So this is rounded off 0.19. Okay, the mine is 0.187. When you round it off, that will be, and see, remember, answer should be given in two significant figures here because this has two significant figures, two decimal places, two significant figures. So answer should also have the same number of decimal places and significant figures. So 0.187 was the answer. So we round it off and we got the answer according to the appropriate number of significant figures, that is 0.19. Okay, a ball of mass, that is question 4, 0.25 kg hits a wall at a speed of 16 meter per second. It then rebounds back along its original path at a speed of 12 meter per second. What is the impulse? So this question is actually related to simply impulse. Anyhow, we will solve it because it's there in the worksheet. So here, initial momentum, here we will have to take this sign convention. If motion towards the right, wall collides the wall. Okay, so here wall is this is our wall. Okay, and a ball is colliding. Ball approaches and collides. Okay, and bounces off. With what velocity it collides? The mass is 0.2 kg, 25 kg, and the initial velocity is 16. Okay, so velocity changes and the return velocity is 12 meter per second. So that is 12 towards left. 0.25 kg, and it is approaching, and its velocity towards right is 16 meter per second. When it bounces off, the velocity becomes 12 meter per second, and now it is negative. Okay, so here impulse means change in momentum. Impulse can be either found out by F into T, but no F, neither F nor time is given. Okay, so we will apply the formula of impulse, that is change in momentum. So change in momentum, final minus initial. M1, no 1, 2, because there is only ball. Remember, wall also gains the momentum in the opposite direction, but it's too heavy body, its momentum is not noticeable, its movement is not noticeable, because during the collision, here law of Newton's third law is applied, both will apply force on each other. The magnitude of the force would be the same. The force by ball on the wall will be equal to the force by wall on the ball. Okay, but here the forces are not ours, neither the time is given, so this part is not to be done. But you remember, the ball beside the ball, wall also gains the momentum. In the same way, when ball collides the ground or some plate on the ground, they gain the momentum. Okay, so here mv minus mu, u initial velocity, v final velocity. 0.25 minus 16, minus 12. Okay? Because the ball bounces off in the opposite direction, minus 12, minus of the formula, 0.25 into 16. So this is 3 minus 3, because 0.25 is 1/4. 1/4 into 12 is minus 3, and 1/4 into 16 is 4. So minus 7. That is the impulse. What is the unit of impulse? Same unit as that of momentum, because this is a momentum, change in momentum. You may either write Newton into second, applying the formula of F into T, change in momentum. Newton, force, time, second. So let us check our answer. 7. Okay. Now question number 5. Two objects X and Y move directly towards each other. The objects have the same mass. Object X has a velocity 0.5 meter per second towards right, and object Y is moving in the opposite direction, that is towards left, and the velocity is 3 meter per second. Okay, so the object F, X and Y, they stick together. What is their common velocity? Okay, we don't know this velocity. After collision, they stick together. It means they have the common velocity. Whether they will go towards right or they will go towards left, that we will find out after working out. If answer comes negative, upper means towards left, as we will be taking left negative and right positive. Same mass. So we can take M for both of them. Okay, so this is M, no M1, M2, because masses are identical. M and M. So what is before collision? Is equal to M into 5 plus m into minus 3. So what is total momentum before collision? This is total momentum. Total P I'm writing. P is the famous symbol for momentum. Total momentum before collision is 5m minus 3m. That is 2m. After collision, they stick together. And where will they go? So P after collision will be equal to, they will be moving like a single body, like this and this. Their masses are added. And what will be their V? So mass M and M, total mass will be 2M. So 2M into V. And as according to law of conservation of momentum, total momentum before collision is equal to total momentum after collision. So what is the total momentum before collision? 2m. Okay, and what is the total momentum after collision? 2m into v. Five m into 3, 5m plus 3m. So that is 2m. And after the collision, they stick together, and they will go with what velocity? This is to be found out. So m and m, 2m, and what is their final velocity? 2m is equal to 2mv. So 2m and 2m cancelled. So what is the answer? V is equal to 1. And what it is coming? Positive or negative? It is coming positive. Means 1 meter per second towards right. Okay. So answer is B. Now question 7. The resultant force of mass, resultant force 500 Newton acts for 10 seconds on a car of mass 1000 kg. Okay, this causes the velocity of the car to double. Okay. So what was the velocity in the beginning? Not given. And the final velocity is to be found out. So we'll have to suppose here. Okay. So final initial velocity, we will say take u, and the final velocity is doubled. So it means we may take it 2u. Okay. So we will first work out the impulse because we have complete data here to calculate the impulse. 5,500 Newton force is acting for 10 seconds. An impulse causes the momentum to change. Impulse is equal to change in momentum. So final P minus initial P. Impulse F into T. 500 into 10 seconds. Is equal to final momentum m, velocity is doubled, 2u minus m u. Initial momentum velocity is u. Okay, we will have to suppose here initial velocity is not given, but it is given that the final velocity is twice the initial velocity. So 2m. And what is the mass of the car? 1000 kg. We will take m common. 2u minus u. 5,000 equals to 1,000 into 2u minus u is u. U is initial velocity. So u is equals to 5 meter per second. So what is the final velocity? Final velocity is 2u. Means 2 times 5, that is 10 meter per second. Okay, answer is B. Now question number 8. At time t equals to 0, a cannonball is stationary inside a cannon. The cannonball is then fired from the cannon. At time equals to t, the cannonball moves forward and the cannon moves backward. What happens to the total kinetic energy and the total momentum of the cannon and the cannonball between t equals to 0 and t equals to t? The diagram here shows 4 bodies. Is something wrong has come in this? So here, this is the table. Total kinetic energy of the cannon and cannonball. Total momentum of cannon and cannonball. So what is the right answer? A says the kinetic energy changes. And what about the total momentum of cannonball and cannon changes? B says kinetic energy changes and momentum remains the same. C says remains the same and momentum changes. D says remains the same, remains the same. So what do you guess? In the beginning, what was happening? The cannonball was stationary. Cannon was also stationary. So initial momentum was 0. So their kinetic energy was also 0. But now they move off and they move, of course, in the opposite direction. Ball moves forward and cannon recoils backward. So the product of mass into velocity of cannon plus the product of mass into velocity of the ball, that will be again 0. Why? Because the cannon will gain momentum in the backward direction, same momentum, though its mass is very huge, but its velocity will be low. Ball is lighter, but its velocity will be high. So their total momentum, because direction will be negative, opposite to each other, total momentum will again be 0, means momentum will not change. But initial kinetic energy was 0, and when they move off in the opposite direction, their kinetic energies will be added. Why the kinetic energies will be added? Because kinetic energy is a scalar quantity, and whatever is the kinetic energy, velocity and mass of the cannonball, and whatever is the velocity of mass and velocity of cannon, that will be added up, and that will be the total kinetic energy. So that will change. It means initial kinetic energy was 0 because they were stationary, and final kinetic energy will be there. But the momentum remains conserved. Since initial momentum was 0, the total final momentum is 0. Okay. For this purpose, you can see the video of second part of momentum again. Okay, this is your cannon. Okay, this is the cannonball. Okay, when it is fired, ball moves forward. Okay, some velocity, and cannon recoils backward. So M into V of cannon will be equals to M into V of ball. So the product will be the same. Small mass, great velocity. Okay, or you can and greater mass, small velocity. MVC minus MVB will be equals to 0. Initially, they were at rest, so initial momentum was 0. So what will come in the what will be the right answer? The kinetic energy changes and momentum remains the same. Now, MCQ number 9. A bullet of mass 0.1 kg travels horizontally at a speed of 600 meter per second. It strikes a stationary A wooden block of mass 1.9 kg resting on a frictionless horizontal surface. The bullet stays in the block. What is the speed of the bullet and block immediately after the impact? So this is the same kind of question as we were doing. Okay, the block was stationary. So initial momentum of the block was 0, but the bullet was having momentum because it was moving at 600 meter per second. And it embeds into the block and they go with the common velocity. Okay, so immediately after impact, what will be the speed? 0.1 into 600. This is the bullet. Moving at 600 meter per second and mass is 0.1 kg, and this is the block. Its velocity u2 is 0, u1. Okay, and this is stationary. Its mass is 1.9 kg. So what will happen? M1 u1 before collision plus M2 u2 is equal to M1 plus M2. Whenever the two bodies stick together, this formula will be applied. 0.1 into 600 plus 1.9 into 0, not in the equation, is equal to 0.1 plus 1.9 into V, that means 2. So this 60 equals to 2V. So what will be V? 30 meter per second. So A is the answer. Now, question number 10. Sphere X collides head-on with a second identical sphere Y, which is stationary. The mass of each sphere is 0.15 kg. The sphere X is traveling at a velocity of 2 meter per second before the collision and produces an impulse of 0.21 Newton into second on sphere Y. What is the velocity of sphere X after collision? What was the momentum of sphere Y? 0, because it was stationary. And it gains the momentum. And what is that momentum? 0.21 Newton. Impulse is change in momentum. Initial momentum is 0. Final momentum is 0.21. So impulse is 0.21 minus 0 is 0.21. Okay, so initial momentum before collision of the sphere X is 0.15 into 2. Zero 0.15 kg moving at 2 meter per second. This is at 0 velocity. Its mass is also 0.15 kg. And after the collision, what will be the velocity V1 of the sphere X? And the momentum of Y after the collision, it changes. Okay, so it moves with certain velocity. So impulse on second ball. Impulse on Y is 0.21 Newton into second. Since impulse is change in momentum, initial momentum 0, so final momentum will be this. Okay, impulse is equal to P2. I'm writing P2Y minus P1Y. Momentum of this is impulse 0.21 P2Y minus 0. So final momentum is 0.21 Newton of this. So what is the velocity of this second ball, the sphere Y? V2 is equal to momentum over, how will you get? Momentum divided by mass. Okay, P is equal to M into V. So this is 0.21, 0.15. So this is coming 0.21 divided by 0.15, 1.4. This was moving with velocity of 1.4 meter per second. They did not give the velocity, but they gave the momentum. So, and initial was 0, so we could easily find out the velocity with which sphere Y started moving after the collision, that is 1.5 meter per second. So what was the velocity of this? We can now easily find out. Since this momentum is 0, we will not include this. The total momentum is P before collision 0.15 into 2. 1.15 into 2 is 0.3. Okay, so we can now do it. Total momentum before collision is equal to total momentum after collision. 0.3 is equal to M1 V1 plus M2 V2. We know the product. Actually, we didn't need to find out this. Okay, we could have written this directly. 0.21. 0.3 equals to 0.15 into V1 plus 0.21. Product of mass into velocity is 0.21 into 0. 1.4 into 0.15 is 0.21. This is now 0.3 minus 0.21 equals to 0.15 V1. So 0.3 minus 0.21 is 0.09. The velocity with which the sphere sphere X will move is 0.6 meter per second. Since the answer is coming positive, means towards right. So what will be the answer here? Here 0.6 meter in the opposite direction to Y, 0.6 meter per second in same direction. These two answers are not the right answers because we are getting 0.2. So which one is the right answer? In the same direction as that of Y, because our answer is coming positive, not negative. If it would be negative, we could have written opposite to that. Now, structured questions. The first question is from IGCSE. The year is mentioned here. So here, figure 1.1, the year is October, November 2020. Shows an ice hockey player moving on ice. He is preparing to hit the solid disc called a puck. Okay, so he's going to hit the puck. The disc of mass 0.16 is moving horizontally across the surface of the ice at a speed of 15 meter per second. Your disk of mass is moving horizontally at 15 meter per second. Calculate the magnitude of the momentum of the disk. So what will be the magnitude? It's an easy part. 0.16 into 0.16 into what will come here? 15 is equal to 0.16 into 15 is 2.4. 2.4 Newton into second or kg meter per second. Okay, so this is the answer of the momentum of the disc. Now the hockey player strikes the disc with his hockey stick to the momentum of the disc and the momentum of the disc changes. The disc gains momentum 3 kilogram meter per second at 45 degree to the original direction of the disc. Initially, suppose this was moving horizontally. Now the disc gains, the momentum of the disc changes and the change in momentum is given. Delta P is 3 kg meter per second. Okay. So this is the initial. Okay, what will the here you will have to draw the vector diagram. Okay, for the vector diagram, either you do it by head to tail rule or head to parallelogram method. State the magnitude of the impulse exerted on the disk and the direction in the degrees of the impulse relative to the direction of original direction of travel. So here magnitude of impulse will be what? It's already worked out 2.4 kg meter per second and the direction is 45 degree to the original direction. So this answer is already there. So I will just okay, and 45 degrees to the original direction. Okay, this is the only one mark because only you have to just tell what is the impulse of the disk. Impulse is change in momentum of the disk. That was moving initially along the horizontal. Now it moves 45 degree to the original direction. Okay, now so determine the new momentum. The new momentum, final momentum. So delta P is equal to P2 minus P1. Delta P is known to as 2.4 and P1, but we can't simply subtract. Why? Because it's a vector diagram. So you will have to draw the vector for this purpose. Okay. So here, this is the protractor. Here the question is solved also. So both the ways are given. So initial is, let me get the protractor. So initial direction is 45, it is right, according to the protractor, because I have reduced the size a little. But anyhow, its initial direction is between 40 and 50. Okay, so 45. And the resultant is drawn here and it's coming around 26. Okay, and this is drawn by parallelogram method. And this is drawn by head to tail rule. Initial direction P1 and change in momentum. So you will have to measure the length here using a ruler and that will give you the magnitude and angle is in both the diagrams the angle is same, that is 26 degree or 25 degree with respect to initial direction. Okay, so this will be your direction of change in momentum. So here you will have to measure the length using the ruler, okay, of this or this, that one, and then the direction also. This is to be filled in here. Okay, whatever angle it makes the new momentum of the disk with the original direction. Okay, so here there is some little working. P2 minus P1 is delta P. So here the head to tail rule is obeyed. That is this plus this. P1 plus change in momentum that is equal to P2. Okay, so P2 will be found out after measuring the length using the ruler. Okay, now let us go to the next question. A spacecraft of mass 300 kg is moving. This is now from GCE O levels. Okay, so 22, 2000, paper 22 and October, November, and year is 23. Recent paper. Spacecraft of mass 300 kg is moving in a straight line in space at a speed of 8,000 meter per second. Calculate the momentum of the spacecraft. So if you calculate the momentum of the spacecraft, what will you do? 300 velocity is 8,000, mass 300 into 8,000, that is 2,400,000. Yeah, so 8 3 is 24 and 2 zeros, 2,400,000. kg meter per second. The fuel on the spacecraft explodes and the spacecraft splits into two parts. The direction in which the parts move does not change. Okay, that means they continue moving in the same direction as they were moving when they were in one body. It did not split. Okay, so after the explosion, the speed of the rear front part of increases to 9,000 meter per second. It has a mass of 150 kg. It means they divide into two equal parts. Okay. One part has the front part, 150 kg is the mass, and the velocity of the front part is 9,000 meter per second. Calculate the speed of the rear part after the collision. So what we will do here, 2,400,000 is the initial momentum. Initial momentum is equal to total final P. Okay. So 2,400,000 is equal to momentum of P of front part plus P of rear part. They are asking to calculate the velocity of rear part. 2,400,000 is equal to, this is 150 into 9,000 plus 150 into V. What the momentum of this comes? 150 into 9,000 is equal to 135 and 4 zeros plus 150 V of rear part. So 2,400,000 minus 135 is equal to 150 V. So 2,400,000 that is 105 4 zeros is equal to 150 V. So V is 7,000 meter per second. Rear part moves with the velocity of 7,000 meter per second. Okay, so this is done. The total kinetic energy of the two parts after the explosion is greater than the original kinetic energy of the spacecraft. But according to law of conservation of momentum, what happens? The momentum, the total energy remains the same. Here, what is happening here? Actually, total energy is same. Some energy comes from the fuel. Okay, state the chemical energy of the fuel also converts into the kinetic energy of the front part, okay, which gains more velocity. Okay, the two parts now have the total kinetic energy greater than the before. Now the explosion lasts for 0.20 seconds. The average force on the front part during this time, you have to find out. Calculate the average force on the front part. So what was the initial momentum of the front part? That was a part of this spacecraft. Okay. So here 150 into 8,000, because that was a single body moving at 8,000 meter per second. So initial momentum of the front part was 150 into 8,000. P of front part is equal to 150 multiplied by 8,000 kg meter per second. And final P of the front part, that was velocity was 9,000. That is 135. One zero is extra. So force is change in momentum. Okay, so F is equal to mv minus mu over t. The time for which the force acts is 0.2 seconds. So initial momentum 1, 2, 0, 1200,000. 1200,000 minus divided by 0.2. So I will calculate this. Minus 135 divided by 0.2. So 750,000 minus. Minus y minus is coming because I have written initial momentum here. So if I write the right way, this will be positive. I have written okay, so answer is positive. Okay, now this is done. Now there is another question, and this is again from IGCSE, recent paper, October number 2023, variant 42. A balloon of mass 15 gram is glued to a straw. The straw is threaded onto a horizontal string as shown in figure. The balloon is filled with air and then the air is released. Well, of course, this is a rocket case, same as that of rocket case. So the air will eject from the nozzle here, backside. The air will apply push force on the balloon. Balloon will move forward and air will gain momentum in the backward direction. Okay, so that is easy. That moves easily because it is glued to straw, and straw is passing through the thread. So that will move along the thread. As the air leaves the balloon experiences a force. The balloon accelerates from rest until it reaches a constant speed. then travels the 0.67 meter in 0.18 second at this constant speed. Explain what is the meaning of impulse. So product of force into time is impulse, and that is equal to change in momentum. This is what you will write here. And then calculate the resultant impulse on the balloon while it is accelerating. So when the balloon accelerates, what will happen? You have to find out the resultant force acting. F is equal to ma. So we may apply formula. F is equal to ma. Initial velocity is 0, and the it starts from rest, as is mentioned in the question. The balloon starts from rest, initial velocity is 0, and it reaches the final steady speed. So how can we find out the final steady speed? It's not given, but the distance with which distance it travels with that speed is given, and the time is also given. So we can make use of this formula, that is distance divided by time, to calculate that constant speed. Okay, so final speed we will calculate, and time 0.18 second. Now this has become easy. F is equal to ma. A is equal to V minus U over T. You may apply change in momentum over time also. That is the same, because if you write here mv minus change in momentum over time, because v minus u, mv minus mu, change in momentum divided by time. So this is the same, 0.18. What is the velocity? 0. I think I have written mass wrong. Let me check. What is the mass? This is the time. The mass is 15 gram. So gram is to be converted into kilogram. Don't forget converting it. Zero point 0.015. This is 15 gram. So divided by 1000, 0.015 kilogram. Okay, and this is the mass. So 0.015. And what is the acceleration? Velocity, we will initial velocity u is 0, and final velocity, because that moves with the constant uniform velocity, it travels 0.67 meter in 0.18 seconds. So 0.67 divided by 0.18. I'm doing it with F is equal to ma, 3.72 meter per second. 0.1015 into 3.72 minus 0. And what was the any data missing? F is equal to ma. So A is any data missing? The resultant, they have asked to calculate the resultant impulse, not the force. Okay, so the time is not needed. Okay, so impulse, change in momentum. So we will now, that thing has become easier, not the force. Sorry. I thought this is the force, so change in momentum. So this is the case simply. This all is not needed. Only change in momentum. Final momentum minus initial momentum. So this is 0.015 into 3.72. 0.015 into 3.72. Here, I have written minus sign by mistake. Minus 0. 0.15 into 0 is 0. So your this is coming 0.0558. Delta P, impulse. Okay. So 5 into, you may write 0.056. As we have two significant figure in this value of mass. Okay, two significant figure in the value of velocity, distance, two significant figure in the value of time. So two significant figure in the value of the change in moment, right? So that's not the end of the question. I explain how the momentum is conserved as the balloon accelerates. Since balloon gains momentum in the forward direction, air moves in the opposite direction. Air is propelled in the opposite direction. So air gains momentum in the opposite direction. Total momentum of air will be opposite to the total momentum of balloon. Okay, so, and that will be same. Gain in momentum of air is equal to gain in momentum of balloon. Momentum in opposite direction. Okay, and momentum of air and this will be same. Now the direction of the two forces acting on the is shown. When the balloon moves, the forward force is 0.4 Newton and the weight is this 0.74. Determine the magnitude and direction of the resultant force. So what we will do, we can do it either by parallelogram method, or you can do it by head to tail rule method, or you can, because they are at 90 degree, you can apply Pythagoras theorem. Okay, here I am doing it by Pythagoras theorem. So what will be the resultant force and the magnitude for the direct magnitude? You have to tell the direction. It means you have to draw it. Otherwise, you can find out the direction by y over x, tan inverse y over x. I will take this figure. So you have to take the appropriate scale. Okay, you may take 0.14, 0.1 Newton equals to 1 centimeter. So what will be the scale? 0.1 Newton is equal to 1 centimeter, means 0.4 Newton equals to 4 centimeter. So this line has to be 4 centimeter longer. Okay, that is 0.4 Newton. And this one will be because 1 centimeter is with this one. So this one will be 0.74 centimeter longer. If you do it by parallelogram method, then Okay, so this is the direction. You have to open the compass here of this length 4 centimeter. You have to keep the compass at this point. Say this is point A, point B, and draw an arc. This arc will come this way. Then cut this arc then place the compass here and put it here, and you will get the arc here. So you will get the length of this, and this. What will be the resultant? Starting from the tail to this. So this will be the magnitude. You will measure the length and this angle, either with respect to this 0.4 Newton force, or that is x-axis direction. Okay, or with y-axis if you want to take, and this one will be this angle. Angle is to be measured. If you are doing it by head to tail rule, this force 0.4 and this force this way, and this is the resultant. Resultant has its tail attached to the tail of the first vector. First vector is 0.4 and second vector 0.7. You can alter also. You can draw it this way, 0.74 first and 0.4 later, but follow the rule. That is, tail of the resultant joins the tail of the first vector, and head of the resultant joins the head of the last vector. So measure the length. In all the three cases here, the length will be the same. Now, other method, that is Pythagoras theorem, resultant force is equal to force along x-axis plus force along y-axis. 0.4 square plus 0.74 square, and this is to be square rooted. Hmm. 0.4 square plus 0.74 square. .84. The magnitude is coming 0.84 Newton. Okay, direction, measure the angle, or direction is what? Tan inverse y, theta equals to tan inverse y over x. You may use this formula. Y is 0.74, x is 0.4. You can calculate the direction using this. That will give you angle with respect to positive x-axis. Okay, so this was the last question. Relative to the horizontal force you have to mention, and it means the direction is to be given with respect to points. Okay, so this is done. This was all for today, and now I will give another lecture later on very soon. The topic I'm not telling right now, and the link of this worksheet will be given in the description box. Okay, you may take this worksheet from there. Okay, Allah Hafiz.